Today in this video I am going to discuss about some important problems from the chapter probability distribution. As you can see, I have written that one too. Now all these questions are taken from the book of Amritava Gupta and the exercise number is 5.10. So I have selected few questions from the exercise, and you can see I have also, for your convenience, I have written all possible questions here and along with their solutions in the proper way. Now here let us discuss about the first question. Suppose fx denotes the distribution function corresponding to some random variable x, then we have to show that probability that a less than x less than b can be written in the form of f of b minus 0 minus f of a. And similarly for the second one, probability that a less equal x less equal b can be written in the form of f of b minus f of a minus 0. Now here you can see these two definitions are actually elementary definitions. We can easily prove this too with the help of the basic properties of distribution function. So first of all, let us consider these two events, a less than x less than b and x equal to b. So whenever we are including this event x equal to b, definitely the outcome will be the event of the form a less than x less equal b. And obviously you can understand these two events have nothing common between themselves. So consequently you can say the left hand side, whatever you have written, these two events are actually mutually exclusive. Now let us assign probability on either side. So p of this entire expression should be equal to p of, like this. Actually you can write p of a less than x less than b plus x equal to b, and that will be equal to p of a less than x less equal b. But because I have already mentioned, these two events are what, mutually exclusive, and hence you can say these two things can be split in the following fashion, that is p of a less than x less than b, that is plus p of x equal to b, and also right hand side will give you p of a less than x less equal b. Now no need to change the first quantity, but for the second one, because we know p of x equal to b can be written in the form of f of b minus f of b minus 0. So definitely we can write this expression by means of this distribution function. Similarly here, just remember the basic definition of distribution function, p of a less than x less equal b, actually it means fb minus of fa. So hence you can say, you can cancel out f of b from either side, so the resulting portion will be p of a less than x less than b, that is equals to f of b minus 0 minus of fa. This is the proof of the first part. That means here we have actually followed the basic definition, nothing else. Now in the second part, p of a less equal x less equal b should be equal to f of b minus f of a minus 0. Here also you can see we have to consider two different events. Just like before, here I have taken x equal to a as one event, a less than x less equal b as the second event. Again you can consider on the right hand side whatever I have written, these two events are actually mutually exclusive. So considering probabilistic value on either side, that is p of a less equal x less equal b, you must have p of this entire expression, but because they are mutually exclusive, so you can write first part is what, p of x equal to a, plus second part is what, p of a less than x less equal b. Now this part by definition of distribution function can be written like fb minus f of a. P of x equal to a, again using the basic definition we can write f of a minus f of a minus 0, whereas the left hand side you need not to modify anything. So ultimate conclusion is that f of a should be cancelled, and the final result is what, f of b minus f of a minus 0, and this completes the proof of the second portion. So you can see the first two properties are nothing but elementary properties. We can directly prove these two things from the basic definition of distribution function. Now moving on to the next problem, you can see as per this exercise, this is question number 3. This question is to some extent a little bit different. The spectrum of the random variable capital X consists of the point 1, 2, 3 dot 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 n. So one thing is certain, because you are the choosing spectrum points in an individual manner, so definitely it is going to be what, going to be a discrete distribution. In the class several times I told you what is the difference between continuous and discrete distribution. Whenever you can choose the points, spectrum points in an individual manner, one after another in a subsequent style, then you can say the distribution must be discrete. And whenever instead of choosing them individually you are considering the overall range, that will be considered as continuous distribution. So here it is given that probability that x equal to I is proportional to 1 by I into I plus 1. This is I plus 1. Then we have to find out the distribution function of x, and after that we need to find out two probabilistic values, of which the first one is p of 3 less than x less equivalent, and the second one is p of x greater than 5. So first task is to find out the distribution function. So here you can easily understand the spectrum points are varying from what, 1 to 3 dot 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 n. So in general we know in case of any discrete distribution, the general way of representing the spectrum points is xi equal to I. Here I have written that one too. For I varies from 1 to n. That's why I have written I equals to 1 to 3 dot 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 n. Now as per given condition of this problem, probability that x equal to I is proportional to this quantity. So p of x equal to I is proportional to 1 by I into I plus 1. Here also you can see I is equals to 1 to 3 dot 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 n. Everywhere you can write down the corresponding criteria for I. Now let us proceed further. So whenever we have seen that probability that x equals to I is proportional to this quantity, so that means some proportionality constant will be required to understand this one. So that's why I have introduced this proportionality constant, that is say k. Now here you can see ultimately we can write probability that x equals to I, that should be written in the form of k into this entire expression, where k is nothing but a proportionality constant. Now definitely you can understand, if we consider all possible spectrum points and if we want to find out the respective probability, then the totality will be 1. Now here the spectrum points varies from 1 to n. Theoretically obviously we know I varies from minus infinity to infinity, but in this practical sense you can say as the spectrum point varies from 1 to n, so the summation should be replaced by I is equal to 1 to n. So that's why probabilistic value of x equal to I under summation where I varies from 1 to n should be equal to 1. But probability that x equal to I is already given by this expression, so just put this. Now you have to split this in terms of two different quantities. So you can easily understand, we can split this expression as 1 by I minus 1 by I plus 1. Now in an individual manner, first of all put I is equals to 1, so the outcome will be 1 minus half. Second part will be what? Putting I equals to 2, 1 by 2 minus 1 by 3. In this way you can continue. So if you put I is equals to n, the result will be what? 1 by n minus of 1 by n plus 1. And the final outcome will be on the right hand side, that is equal to 1. No need to change anything on the right hand side, it is fixed. Now you can see half will be cancelled. 1 by 3 will be cancelled. In this fashion everything will be cancelled except the first and the last. So 1 and this 1 by n plus 1, these two quantities should survive, and ultimately you will get k into 1 minus 1 by n plus 1 should be equal to 1. That means after simplification you will easily find out the value of k, as we have obtained here k is equals to n plus 1 by n. Now once you have obtained this value of k, put this value in this expression so that you will get the exact structure of probability that x equals to I. Now what is our objective? We need to find out the distribution function. That's why first of all we can consider minus infinity less than x less than 1. Because the spectrum point starts from 1, so whenever you are considering this range, it is obvious it will represent the event corresponding event space or event structure corresponding to the impossible event. So f of x in this case will be p of phi, and that's why the outcome should be equal to 0. Now we can choose any point of the form r to r plus 1. So this range contains the point x. Obviously r can vary from 1 to n minus 1. Why? If you put r is equals to 1, then x should lie between 1 less equal x less than 2. If you put r equals to 2, then 2 less equal x less than 3. If you put n minus 1, then it should be what? N minus 1 less equal x less than n minus 1 plus 1, that will be equal to n. So in this case distribution function as per definition p of x less equal x can be written as what? P of summation x equals to I varies from 1 to r, because you are considering different points, that's why summation should be implemented here. Now actually you need to consider the probabilistic value, so in the next line it can be modified in this fashion, and hence you can say Once you have obtained the value of probability that x equals to I, remember we have obtained this structure, so put it here. Then after simplification you can easily understand n plus 1 by n has nothing to do with this summation, so take this one out from this summation. Then you will get summation I is equals to 1 to r 1 by I into I plus 1. Now just now we have seen whenever we want to split this summation, the outcome is what? N by n plus 1. So here the outcome will be what? R by r plus 1. Why? Because whenever the summation varies from 1 to n, the outcome is n by n plus 1. So whenever it is varying from 1 to r, the outcome should be r by r plus 1. So this is the distribution function within this range. And finally, whenever you are considering n less equal x less than infinity, then obviously you can say distribution function corresponds to the certain events probability, and hence it should be 1. Now whatever you have obtained, just provide the distribution function for each and every possibility, and that's why we have obtained the distribution function of x like this. Fx equals to 0 whenever we are considering this range, fx equal to like this whenever r less equal x less than r plus 1. Remember, r is nothing but 1 2 3 dot 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 n minus 1, and finally it should be equal to 1 whenever n less equal x less than infinity. So this is the criteria for distribution function. Now we need to find out these two probabilities, p of 3 less than x less equal n. Now remember, we know p of a less than x less equal b, this is fb minus f of a. So using this definition we can say this part should be f of n minus f of 3. F of n, what is the meaning of this expression? Whenever n less equal x less than infinity, fx is what? 1. That means f of n is 1. Similarly, whenever you are considering f of 3, that means you need to use the range of this expression. That means if you are considering n equals to, r equals to 3, that means what will be the outcome? In this case 3 by 4 n plus 1 by n, this type of structure will be obtained. So I have written the same thing and just simplify this expression, then you will get this result. So here probability that 3 less than x less equal n will give you this type of structure. Now probability that x greater than 5 can be imagined as 1 minus p of x less equal 5. So here it will be what? 1 minus f of 5. So just like here, you can also consider this structure. So here n plus 1 by n, no need to change this one, but it will be 5 by 5 plus 1, and hence you can see I have written 5 by 6. Again simplify this structure, you will get your required probability. So in this fashion you can find out the desired result. Now after that, moving on to the next problem, let us discuss about question number 4. As mentioned in this exercise, the distribution function of certain random variable capital X, that is fx, is given by this structure. As you can see, ABCD are 4 unknown quantities. We have to determine ABCD, where the respective ranges are also given, and also two conditions are given to you so that you can solve this problem. That is probability that x equal to 0 is 1 by 6, probability that x equal to x is greater than 1, that is equals to 2 by 3. So you can start in the basic format. You can say the given distribution function is like this. Now remember two important properties which we have discussed earlier in our classes. F of infinity is 1, f of minus infinity is 0. Also I have given the proof of these two properties. So f of infinity is 1 means you can consider limit extends to infinity fx, but you have to consider this particular range at that moment. So the outcome is what? D. So that's why you can see here I have written D. Whenever you are considering f of minus infinity, in terms of limit you can write limit extends to minus infinity fx. That means you have to consider the first possibility. Outcome is what? A. So that's why you can see I have written A. Now probability that x equal to 0, that is 1 by 6. Probability that x greater than 1, that is 2 by 3. These two conditions are given. Now remember, x equal to 0, probabilistic value of this expression is 1 by 6. What does it mean? As per definition of distribution function, you can write f of 0 minus f of 0 minus 0, that is left hand limit of 0, that is equals to 1 by 6. What is f of 0? Just follow this one, 0 less equal x less than 2, that is C. Put C here. f of 0 minus 0. What is the meaning of this? Left hand limit of 0. That means you have to consider this range, because in this case x is less than 0, so it should be less than 0. So you are considering the left hand limit, so you have to take this particular structure, that means b. So c minus b equals to 1 by 6. Now probability that x is greater than 1 is 2 by 3. You can take the help of complementation, that means 1 minus p of x less equal 1 should be equal to 2 by 3. What is the meaning of this structure? 1 minus f of 1, you can consider this thing. What is f of 1? Again take the help of this structure, 0 less equal x less than 2. 1 is lying between this range, so ultimate outcome will be c. So 1 minus c should be equal to 2 by 3. From here you can easily get the value of c, that is 1 by 3, and accordingly putting this value in this equation 1, you will get the value of b. So a, b, c, d, all these possible results are considered as 0, 1 by 6, 1 by 3 and d equals to 1 respectively. And this is the required criteria as per this question. So you have obtained all possible values of a, b, c, d. So let us consider the next problem. This one is a very important problem. This is question number 9, and this is extremely important. That's why you can see even I have written this is very important just above this question number. Suppose capital X is a binomial n comma p variate. N is the number of trials, p is the probability of success in each trial. Then you have to show that probability that x less equal k can be written by means of this ratio of these two integrals, where q can be considered as what? Probability of failure. So q is 1 minus p, and k is lying between 0 and n minus 1, and it is an integral value. Now obviously we don't know what type of structure you should initially obtain for probability that x less equal k, but one thing is certain, you have to start with the PMF of binomial distribution, and also you have to write down the corresponding spectrum points. So we can start in this fashion, that we have the spectrum point like xi is equals to I, PMF fi is equals to like this, probability that x equals to I, which can be written as what? NCI p to the power I q to the power n minus I. We know this is the criteria for binomial distributions PMF. Obviously I is starting from 0 and it can carry up to n, I equals to 0, 1, 2, 3 dot 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 n. Now probability that x less equal k. Suppose k is 5. What does it mean? Whenever you are writing probability that x equals to I may be 0, I may be 1, I may be 2, continuing in this fashion, you have to carry up to 5. So simply you can abbreviate this one by writing probability that x equals to I under summation, where I varies from 0 to k. Now what is the meaning of probability that x equals to I? You know what is the probability mass function, so simply write this one, summation I varies from 0 to k, not 1 to k, sorry, NCI p to the power I q to the power n minus I. If possible, let this be equation number 1. Now imagine this part is ik, whatever we are given on the right hand side. Why I have taken this one as ik? Depending on this power. Okay, you can see this power is same for both the structures, so I have written this one as ik. Now numerator remains intact, but in the denominator we are performing certain modifications. 1 minus x whole to the power k, this can be written as 1 minus x whole to the power k plus 1 minus 1. What is the meaning of this particular structure? Numerator, no need to change it, but we know from the definition of beta function, beta mn can be written in the form of 0 to 1 x to the power m minus 1, 1 minus x to the power n minus 1. So compare this particular structure as m and this particular structure as n, so that we can write the denominator portion can be rewritten in the form of beta of n minus k comma k plus 1. In the next line, no need to modify the numerator again, but we know beta mn can be written as what? Gamma m gamma n by gamma m plus n. So this part can be written as gamma of n minus k, gamma of k plus 1, then gamma of m plus n, that means n minus k plus k plus 1, k will be cancelled, so that you will get gamma of n plus 1. So again gamma of n plus 1 can be written as what? Gamma of n plus 1 is actually n factorial, we all know this. and gamma n minus k will be what? N minus k minus 1 factorial, because n plus 1 gamma of this expression becomes n factorial. So if it is n plus 1, you are getting n factorial. So similarly, gamma of n minus k, it will be n minus k minus 1 factorial. Similarly, gamma of k plus 1 will be k factorial. So in the next line, you will see I have written the same thing, just converting all these expressions in terms of factorial notation. Now you can integrate this structure, whatever you have written in the original part. That means you can integrate this entire portion from 0 to q. Obviously you can take the help of integration by parts, so keep this first part intact. Now you can integrate this one. Say this is the second function, this is the first function, or you can choose this is the first function, this is the second function, u into v. So u remains intact, you can consider, and v should be integrated. So x to the power n minus k minus 1 plus 1, so x to the power n minus k will appear, and in the denominator portion also you will get n minus k. Integration should be done from 0 to q. Accordingly you have to differentiate this structure. So k into 1 minus x whole to the power k minus 1. Then in the denominator portion again n minus k will appear, because there is a minus sign in front of x. Whenever you are performing derivative, a minus sign will also appear. That will adjust the intermediate minus sign into plus sign. Now here you have to put x equals to q initially, so you will get first structure. Putting x equal to 0, you will get the second part is trivially 0. Here also you can understand, you can multiply this entire structure by this first factorial expressions. N minus k minus 1 factorial into n minus k gives you n minus k factorial. N factorial k factorial remains same. Similarly for the second part, n factorial remains same, k in the denominator portion k factorial. So after cancelling the common factor k, you will get k minus 1 factorial. N minus k minus 1 factorial multiplied by n minus a will give you n minus k factorial, and on the right hand side you will get the usual structure. Now what is the meaning of this? This particular portion is nothing but nck. That's why I have written this thing. This is p to the power k. Why? 1 minus q is equals to p, that's why. Similarly second part is q to the power n minus k. Now in the second part you need not to do anything, but just remember, as I told you earlier, this portion is k in the power. That's why I have considered this entire integral as ik. So whenever we are considering, the power is little bit different. What is the power? N minus k x to the power n minus k, 1 minus x whole to the power k minus 1. So automatically this structure can be written as what? Ik minus 1. So we have so far obtained the value of ik, because from here you have started your calculation. So ik is equal to nck p to the power k q to the power n minus k, and now plus ik minus 1 will appear. Obviously k is greater or equal 1. Adjust this two, so that you will get ik minus 1 should be equal to what? nck p to the power k q to the power n minus k. Now you have to replace k. Obviously you can need not to write this one, you have to replacing k by k. Consider this one is the initial condition, then you have to replace k by k minus 1 k minus 2 dot 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 3 2 in this fashion. Accordingly you will get all these relations one after another. So final relation will be I2 minus I1 nc2 p square q to the power n minus 2. Now just add all this. You can easily understand, whenever you are writing all this, these portions will be cancelled, and so first and the last part will exist, that is ik minus I1 summation nci, where I varies from 2 to k. That's why you can see this expression p to the power I q to the power n minus I. So ik will be I1 plus this expression. Now it's time to find out I1. Now you have already obtained the value of expression like 2, that is ik. Remember, this is the value of ik, whatever we have obtained by equation 2. So putting k is equal to 1 you will get I1. So n factorial remains same. Just put k is equals to 1. You will get n minus 1 minus 1, that is n minus 2 factorial. Then 1 factorial. Here also x to the power n minus 1 minus 1, that is x to the power n minus 2, and then 1 minus x. So here you will see the same thing has been written, and also for your convenience I have written using 2 we can obtain this structure. Factorial n by n minus 2 factorial, this will be n into n minus 1, 0 to q, multiply this expression x to the power n minus 2 minus x to the power n minus 1. Just normal multiplication will give you this structure. Now you need to proceed further to get your desired result. In the next line you will see I have integrated this structure. That means you can see I have written n into n minus 1, no need to change this structure. After integration you have to put the upper limit and lower limit, that is q and 0. So putting upper limit minus lower limit, you will get this type of pattern. So n minus 1 will be cancelled, n into q to the power n minus 1, then n will be cancelled, n minus 1 into q to the power n. Now split this one. So first part remains same, n q to the power n plus q to the power n. So this particular portion q to the power n can be written like q into q to the power n minus 1 with the help of law of indices. Now take q to the power n minus 1 as common, then n minus nq will appear, q to the power n, this is the second term. As usual you can see, take q to the power n minus 1 common, n common, so 1 minus q will be there and q to the power n will be there. Now q to the power n intentionally adjusted as nc0 p to the power 0 q to the power n minus 0, because nc0 is 1, that's why. Similarly nc1 can be written in place of n. 1 minus q is what? P, so I have written p to the power 1, then q to the power n minus 1. This is the value of I1. Now remember, already we have shown that ik is what? I1 plus summation I is equal to 2 to k. So practically we have obtained nc1 and nc0 also, so that we can say using this result in the previous one, new result of ik will be like this: nci p to the power I q to the power n minus I. This is varying from 0 to k, and thus from our initial assumption and from this assumption we can say what? These two things are identical. So probability that x less equal k, what does it mean? Maximum you can get k number of successes. So I is equals to 0 to k. We are considering summation over this expression should be equal to ik, where as per our assumption ik is like this, and this is the required proof of this problem, and this problem is very important. Now let us discuss about another important problem, question number 27. PDF of a random variable x is like this: 2x into e to the power minus x square for x greater than 0, elsewhere 0. Then we have to find out the probability density corresponding to x square. Very simple one. Fx can be written like this: for x greater than 0 you have this type of structure, elsewhere it should be 0. Now let us take the substitution y is equals to x square. You can see I have written this one. So in terms of real variable it will be small y is equal to x square. As you have changed the variable, so you need to find out dy dx. So that's why in the next line you can see I have obtained dy dx, that is 2x. Now if x is greater than 0 as per mentioned in the question, so 2x is also greater than 0. That means there is no fluctuation in the sign corresponding to dy dx. That's why we can write dy dx maintains the same sign as that of x greater than 0. That is, whenever x is greater than 0, we must have dy dx is also greater than 0. Now use the transformation formula. So fyy will be fxx multiplied by mod of dx dy. Use the value of fxx. Dy dx is 2x, so mod of dx dy will be 1 by 2x. 2x to x will be cancelled, and hence you will get e to the power minus x square. But what is the value of x square? Y is equal to x square. This was your substitution, so it will be e to the power minus y. And hence you can say whenever x tending towards infinity, y is also tending towards infinity, and x is non-negative, so y is also non-negative. That means the range for y will be 0 less than y less than infinity, and hence required density function, probability density function for y can be written like this, or you can simply write f of small y is equal to e to the power minus y whenever you have this type of structure, and elsewhere it should be 0, and this is the required result. Now there is another important problem, that is question number 28 as per this exercise. If x is a normal 0, 1 variate, find the distribution function of e to the power x. As usual, you can say x is a normal 0, 1 variate means it is a standard normal variate. So first write down the probability density function of x. We all know the range is minus infinity to infinity for x, and it will be, density function will be 1 by root 2 pi e to the power minus x square by 2. And so that you can say, choosing the structure y is equal to e to the power x, that means we have taken this substitution. In terms of real variable, we can write this one as what, small y equals to e to the power x. Now find out dy dx, also find out the respective range. When x tends to infinity, as per our structure, y is also tending towards infinity, because x tends to infinity imply y is equivalent to e to the power infinity, which is also infinity. X tends to minus infinity means e to the power minus infinity, that is 1 by e to the power infinity, which is tending towards 0. So y will be in this case 0. Now suppose FIY is your required PDF corresponding to the function y, or corresponding to the random variable y. So FIY using transformation formula can be written as fxx multiplied by mod of dx dy. So put the value of fxx, also mod of dx dy is what, my e to the power minus x, because remember you have already obtained dy dx is e to the power x, so its reciprocal will be e to the power minus x. Just simplify this one, e to the power minus half, then it will be x square plus 2x. Now e to the power x is equals to y, so log y will be x, so here it will be log y square plus 2 log y. Now simply write the respective range for y, 0 less than y less than infinity. Then you can see I have written 1 by root 2 pi e to the power this dot e to the power this. That means we are considering the criteria of, actually this one will be what, whenever you are considering this portion e to the power minus half of this minus half into 2, that will be e to the power minus log y. So we are using the concept of law of indices. Accordingly 0 less than y less than infinity, so 1 by root 2 pi, this portion gives you y, so here you can see y is there, e to the power minus half of log of y whole square, provided 0 less than y less than infinity. Now e to the power minus log y can be written as e to the power log of y inverse, and we also know e to the power log x is equals to x, so consequently e to the power log of y inverse should be what, y inverse, that is 1 by y. So you can see 1 by y is included in the last line, and thus we have obtained PDF of y will be given by FIY like this, whenever 0 less than y less than infinity, elsewhere it should be equal to 0, and this is the required criteria. So these are some important problems which I have solved for all of you, so that you can prepare all these problems, and if you have any ask, again I will say you can easily satisfy your queries by asking your doubts or clarifying your doubts, and obviously all these questions are very important for your examination purpose as usual. So thanks for listening and watching, and thank you.